Hey everyone, we are going to use one-sided limits to find the value of this k here to make f of x continuous at 3. What we have is a parabola and a line. Our goal is to make these two come together so that it's continuous at 3. So just to illustrate this, I randomly chose 4 for my k, rather negative 4, and just as a choice. And here's how it looks where it's not continuous. So I want to find the right value of k, so I need to change the slope so that this guy is continuous. That's the goal here. But really our goal is learning to use proper notation. So that's the really big thing, and I'm strict on notation. You'll learn that about me. And also later in the year we're going to see another similar looking problem, so you need to have the notation now while it's still a little less complicated. So that's the whole purpose of this. So we need these two guys to come together from the left, that is on the parabola, and from the right on the line, and have them come together and meet. So we're going to use one-sided limits to show this. So I have the limit as x approaches 3 from the left. Remember that sign after the number means it's coming from the left. From the left, we're on the parabola. So I'll put my x squared plus 4x plus 1 here. And we need that to equal coming from the right, so the limit as x approaches 3 from the right, I show that with the plus, of the 27 minus k times x. So this notation is really important. These two things aren't equal to each other except for approaching 3 from both sides. So that's kind of the key thing. So if you'd left the limit notation out, you're not really telling the truth. It's a little bit weird. So now though we can find those limits, so we'll plug in those 3's. So I have my 3 squared plus 4 times 3 plus 1. And since I've plugged in my value of x, that's the moment I drop my limit notation, so that's why it's not there anymore. And that equals, and I can plug in my 3, so I have 27 minus k times 3. From here, it's just a straight solve for k, no big deal. So 9 and 12 is 21, 22 equals 27 minus 3 times k. Subtract 27 from both sides. I'll even show my work. So negative 5 equals negative 3k, dividing by negative 3. And I have k equal to 5/3. So now we need to test to see if this works. So we go back to our calculator, we go to our y equals, we put in, instead of that negative 4, I have 27 minus 5/3 x. I graph this guy. And I can see I've made these come together in a connection at 3. And I will say I did the cheat of, instead of saying a strictly greater than, I used the greater than or equals. So that way, when I look at my table and I look at the 3, I can see that 22 is on both of them. So I've checked my work. I've used the proper notation. This is the bit of notation people leave off. Don't do that. Besides that, it's pretty straightforward-ish. And by the way, just as a reminder of vocabulary, the feature we get on that function, that as it comes together, we have that parabola and our line. And that feature on that pointy bit is called a cusp.